Okay, good day class. Alright, so we will continue with 5.1.2.2 and ellipse with the center HK. So what we have done before is how to get the info from the ellipse with center or origin, where this is the center form, and from here we can know that the center is the origin, and from here also we can find the focus, vertices, and also latus rectum. Okay, now we will see how about ellipse with the center HK, means not at the origin. Alright, so the equation of an ellipse with the center HK is defined like this. So this is the standard form. It's a little bit like circle. So when the center is HK, then just x minus h, y minus k. As usual. And square it. So from here we know that this is the center. H and k is the coordinates of the center. Remember, it's minus. And also the right hand side is 1. Okay, so for ellipse, we have two different conditions, right? Vertically and horizontally. Horizontally and vertically. So this one also the same. Alright, so before we go to the table, let's look at this diagram. Okay, so this is the vertices with center HK. Alright, let's say coordinate HK is here. So this one will be the ellipse. Let's say it is horizontally. So the horizontal line pass through the center, which is y equals k, right? Is the major axis. Okay, and the minor axis will be x equals h. Alright, so we will write the equation of this ellipse in general form in this way. Okay, then look at the table. Alright, so if A is bigger than B, so as usual, if A is bigger than B, alright, so everything will be on x, on the line x equals h. If A bigger than B. Alright, if A bigger than B, then we know that A bigger than B, so it's horizontal like this. So if it is a horizontal shape, then your major axis will be y equals k lah. This one, horizontally, same as x-axis, right? Parallel with x-axis. If A is bigger and A is under x, so remember the major axis is parallel with the x-axis. Alright, so your major axis will be y equals k, this one. Alright, and the vertex here, these two vertex, alright, will be h plus minus a and k. Alright, because the major axis is y equals k, so means all the points lies on the major axis, the y will be k. Same. It won't change. Alright, all the center, foci, vertex, all lies on y equals k. So all these coordinates, the y coordinate will be k. It won't change. The coordinate which change is the x coordinate. Alright, so for these two vertices, very simple. We know that this is a, right? This distance is a square, so this distance is a. Therefore, this distance also a. Right? Therefore, the vertex will be, this is h. Here is h. So this will be h minus a. This coordinate is h. Okay, so go a unit, so h minus a. And this coordinate will be h plus a. Right? So h minus a, h plus a is the coordinates for the vertices. So you see here, h plus minus k. H plus minus a, and y coordinate unchanged, because all the point lies on this line. So all the y must be k. Alright, and the foci also, k won't change. The y coordinate won't change, still remain k, and the foci will be h plus minus c. Right? So h and k is the center, right? H and k is the center. So what this says, h plus minus a. Foci, h plus minus c. Alright, then the minor axis will be x equals h lah. This one. Okay, if you want to find the two endpoint on the minor axis, means these two. If you want to find these 2 points, alright, then it will be h, because it's on the vertical line, x equals h, so x won't change lah. Alright, and k will be plus minus b. So we know that this is b. Here is b. This one also b. This is a, this is b. Alright, this is for a bigger than b. So we follow this one. So remember, with A bigger than B, the major axis is horizontal one, y equals k, this, and the vertices and foci, the y coordinate won't change, still remain k, only the h thing change. And how h change? Vertices plus minus a, foci plus minus c. Alright, then the next one will be this one, when a smaller than b, or when b is bigger. Alright, when b is bigger. So we know that when b is bigger is vertically, right? So the major axis will be, this is the center. This is the center, hk. So this is y equals k. So this one will be x equals h. So this is the major axis now. X equals h is the major axis. This one. This is the major axis. Alright. So the equation is still the same, right? So now, yeah. So now this is A, always this is A, and this is B. Okay, so vertices, because now the major axis is this line, x equals h. So whatever center, focus, vertex, all the x coordinate same, which is h. Or you see, all the coordinate, x coordinate same. Okay, h, only y change. Alright, so how y change? So this is k. This is k. So the upper vertex will be h plus, k plus b. Here is k, so k plus b. So if go down, k minus b. Therefore, the y coordinate is k plus minus b. The b come from here. Alright, and foci, let's say f1 is here, f2 is here. The foci also the same. So you calculate the c. You calculate the c by using this one. Then again, the coordinate for the focus will be x coordinate remain at h. No change. Alright, and the y coordinate will be k plus minus c. Okay, so this table is very useful. So when you want to do the homework or what, always refer to this, so you can get the correct answers. Alright, okay. So this is a standard form of an ellipse with center hk. Of course, if center origin easier. Okay, so if center hk, then you have to remember all these things. Alright, okay. Then next, this is number 2. Okay, this is number 2, wrong. So this is 3, 4, and 5. Okay, so number 2. So when you expand the terms in this standard form, okay, and we simplify it, then we will give us an equation in this form, you see. This is what we call general form. Ax squared plus by squared plus cx plus dy plus e. Okay, where a, b, c, and d and e are real numbers. Okay, and both a and b must be positive, and a and b not the same. Alright, so this is the difference between ellipse and circle. Remember, if circle, then it will be ax squared plus ay squared. The coefficient for x squared and y squared must be the same. Then plus bx plus cy plus d equals 0. Alright, so this is the difference. This is circle. Right? The general form of circle, the coefficient for x squared and y squared must be the same. So for ellipse, you see almost the same, but the coefficient for x squared and y squared not the same. A not equals b. Alright, this is the general form for ellipse. But not like circle. If circle, when we write it in general form, so we can write it in 2gx and 2fy plus c, right? Remember? Then from here we can find the center and also the radius, where it is f squared plus g squared minus c square root. Remember? So if for circle, yes, in general form, also we can get the center and the radius. Okay? But not ellipse. Alright? Not ellipse. When ellipse expressed in general form, we actually can't get any info. We can't get the center or whatever from the general form. Okay, so what we can do is, if we are given an equation of ellipse in general form, we have to do completing the square to express it in standard form. All right, from center form only we can get the info for center, okay, vertex, foci, and so on. All right, this is a different. Okay, so this is the general form of the equation of an ellipse. So do you notice that there is no xy, no xy term? It's only x squared, y squared, x and y. There's no term together with xy. So those who have xy is actually this. Later I will come to this one. All right. Okay. So conversely, if we start with such equation, then by completing the square, we can obtain a form such as this standard form. Okay. Then can help us to get the center, vertices, the length of the major and minor axis, and also the foci. Okay. So how to do completing the square? Same as circle. We have done it in circle, right? Later we will discuss some examples. Okay, then number 4, to show an equation represent an ellipse. So you have to express the equation in standard form by completing the square. Nothing can do. All right, so for example, you see question like this. Show that this equation is an ellipse. How to show? So we do completing the square to express it in standard form of ellipse. If we can do it in this way, then we can make conclusion, yes, it is an ellipse. All right. And number 5, this is the thing. If the equation of an ellipse is in oblique position. So remember, in STPM syllabus, you only learn ellipse, the horizontal ellipse or the vertical ellipse. Actually, the oblique position ellipse is not in your syllabus. But it's good for you to have this information. All right. Why? Actually, it came up once in STPM. There is a question. Yeah, the question is not specific for ellipse for this topic. The question is actually for chapter 1, functions. They give the student one equation in general form, and they ask the students to get some points. Then ask them to sketch. Also, consequently, the points that they get when they mark on the coordinate axis, it seems like just a circle. It really seems like a circle because the coefficient for x squared, y squared also the same. So many students thought that it is a circle. So they draw circle. So wrong. It's actually ellipse or an oblique position ellipse. All right. So the oblique position ellipse will always contain the terms xy. This is what we mean. You see, the coefficient for x squared and y squared might be the same. So when we see same, then circle. No, remember we say circle, no xy. For circle, no xy. All right. If you see coefficient for x squared and y squared same, but with one xy, then definitely this is oblique. This is ellipse in oblique position. All right, but this is not in our syllabus lah. Okay, but it's good for you to know that. So I hope you remember. Again, I repeat. So in general form, this is for circle. The coefficient for x squared, y squared same. Okay, and you see no xy. Whereas for ellipse, the horizontal one or the vertical one, almost same as circle, but the coefficient for x squared and y squared not the same. All right. If you find something coordinate for x squared and y squared the same, but with the term xy, then you remember this is ellipse. It's in the oblique position. Okay. All right. Okay. Now let's look at some examples lah. So I will discuss quite many examples. Okay. So first we will go to checkpoint 5.2. All right. It's page 226. Okay. Question 2, 3, and 4. So please open your textbook. All right. Page 226. Checkpoint 2.2. All right. So we are going to discuss some question in 2, 3, and 4. I just show you. So later I'm not going to show you again. Question 2. Sketch the ellipse. Then find their center, foci, and vertices. Whereas question 3, you are given foci and vertices. They want you to find the equation of the ellipse. And question 4, show that this is vertex. Sorry, this is ellipse. I'll show this is ellipse, and then after that find their center, foci, and vertices. All right, so you can refer to your textbook. Okay, so let's look at question 2. You can see, yeah? Okay. So please look at question 2. I'm going to discuss 2B and 2C. All right, can see. Okay, can see. Here. Okay. So please look at question 2B. So 2B, you are given this equation. X squared over 4 plus y plus 2 squared over 9 equals 1. So remember, always look at right hand side must be 1. Alright, so I write it in the not proper lah, the actual general form. So x without plus minus anything is actually x minus 0. So I write this in square form. Okay, so from here very clear, A is smaller than B. A is smaller than B, so we know that it is a vertical one. It is a vertical ellipse. So the major axis also vertical line. Alright, so next we find the center first. Okay, so from here we know center is 0, negative 2, right? Because it's supposed y minus k ma. So minus, so it's negative 2. So the center is 0, negative 2. 0, negative 2. Oh. Okay, fine. I think... Alright. Oh, so my graph not enough space. Never mind. We continue. Okay, 0, negative 2. So this is the center. Alright. And B is 3, right? Alright. B is 3. So we know that the vertex will be minus 2 plus 3 and minus 3. B is this one ma. See another vertex. If vertically, vertically is H remain the same. The X coordinate same, which is 0. And the Y coordinate is K plus minus B. K is negative 2. So B is 3. So plus 3 is 1. Minus 3 is negative 5. Sorry. Not enough space. Okay, here. So center, vertex. Okay? Then, alright. So we can sketch already. So as I say, we show this one. If you want to find these two endpoint also can because we have A ma. A is 0 ma. So means 0 plus minus 2 unit lo. So it's here and here. Very simple. Okay, so we draw a curve along this 4. Then we join them. This one actually can fatter. Then we join them. We join them. Yes. Alright. So this is the ellipse. It's vertically. It's quite round lah. Alright. Then after that, the question want you to state the center. Alright. Foci and vertices. So very simple. So foci, C square is B square minus A square lah, because B bigger ma. So means 9 minus 4 is 5. So C is plus minus square root 5. Alright? And see here, foci. For B bigger, foci. So we follow this. H, K plus minus C. H remain the same. The X coordinate same. So same as the center. So 0 lah. 0, 0. Okay? And K is negative 2. So negative 2 plus minus C. So negative 2 plus square root 5. Negative 2 minus square root 5. Yes, this is the foci. Alright? And the vertices here. This is the vertices for A bigger. So again, H remain the same, see? H same, but K plus minus B. H, K plus minus C. So H means the X coordinate same. Alright? And the Y coordinate is K plus minus B. K is negative 2. B is 3. Just now we sketch here already lah. So negative 2 plus 3 is 1 here. And another vertex is negative 2 minus 3, so negative 5. Just now we sketched it already lah. Okay? So this is 2B. Okay, then 2C, the question give you this. I show another one, horizontal one lah. Alright? So very simple. The center is, okay, so this is, by right is x minus h ma. So plus means negative 1. No? Okay, so y is 4. So this is the center, negative 1, 4. Oh, negative 1, 4. Okay. Why I sketch so small? Okay, 3, 4. Okay, so negative 1, 4. So this is the center. Alright. Oh, so I need to go up a bit. So, okay, sorry lah. Okay, so this is 3 square, right? Okay, this is 3 square, this is 2 square. So A is 3, B is 2. Okay, so from the center, the vertex will be plus 3. So up to 7, 4 plus 3, 7, 4, 5, 6, 7. Sorry, a bit messy here. Okay, so 4 minus 3. So 4 minus 3 is 1. So these two are the vertex. Alright, this is the major axis. Okay, you can find the end point of the this on the minor axis. Okay, so this is negative 1, right? And your B is 2 ma. So negative 1, 2 unit. So negative 3 lo. Okay, negative 1, 2 unit. So it's 1 here lo. Okay, so this is the ellipse. No. Okay, no. Oh, sorry. I made mistake already. Sorry. I made mistake already. Okay. Sorry. So let's try again. Okay, let's try again. I made mistake, sorry. So let's try again. Oh, finish. Okay, so let's try again. So center, negative 1, 4 is correct. Okay, center is negative 1, 4. Okay, so your A is 3, so it should be like this. Okay, sorry. It should be like this. Plus minus 3. Okay, so negative 1, go back 3 unit is negative 4. Negative 4 here. Yes. Okay, so 3 unit to this side, 1, 2, 3, so it's here. Yes, these two are the vertex center. Because A bigger ma, so the major axis should be parallel to the x-axis. So sorry, I made mistake. Okay, then Y is 4, so B is 2 ma, so up 2 unit and go down 2 unit. 4 minus 2 is here. Okay, so these are the vertices. Okay, now we can join them. We join them. Yes, then you get the ellipse, the horizontal shape ellipse. Okay. All right. Okay, so center will be negative 1, 4 lah, Okay, then for chi also the same. Okay, for chi also the same. So it's A square minus B square. So 9 minus 4, 5 lor. Also C is square root plus minus 5. Similarly to this one. Okay, and because it is horizontally, A is bigger here. A is bigger. So for chi follow this formula. H plus minus C, K. Y coordinate remain the same, K. Okay, H plus minus C, K. So K is 4. Alright, so remain the same. Only the X. So H plus minus C. H is negative 1. So it's negative 1 plus square root 5. So negative 1 minus square root 5 and 4. Okay, this is a 4 chi. Whereas the vertex is same, right? You see, K same. But the vertex is H plus minus A. A is 3 unit. So this is 4. Okay, K remain the same. H is negative 1. So A is 3. Okay, so negative 1 plus 3, negative 1 plus negative 1 minus 3. Go this side ma. So negative 4. Alright, and negative 1 plus 3, 2. Here also have already. In our graph also have already. Okay, so this is how you get this. Okay, so I hope all of you can get it. All right. Okay. All right. Okay, so this is question 2B and C. All right, the next one is question 3. Okay, we will see question 3. All right, okay. Okay, question 3, I'm going to discuss D only. So the rest you will do as homework. Okay, so question 3D is, you are given foci, -1, 4, okay, -1, 2, and the vertices, -1, 3 plus minus square root 3. -1, 3 plus minus square root 3. So means, -1, yeah, correct. -1, 3 plus minus square root 3. So means 1 is plus, 1 is minus lah. So you are given this. Alright, so first thing, center. So actually, before go to center, you see or not? All the x coordinates are the same. You see? All the x coordinates are the same. So it's very clear that x equals -1 will be the major axis. See or not? All the x same as -1. So x equals -1 will be the major axis. So means x equals -1 is a vertical line. So you'll be, from here, I know that this is actually vertical ellipse. Alright? So to find center, remember center is the midpoint of F1, F2. So you use the midpoint formula. Or if you don't use, also never mind. We know that the x must be -1. So 2 and 4, 6. Half of 6, 3 or you show the formula lah. So this is your HK actually. This is the center. Alright. So after you have get your center, because the question wants us to form the equation. To form the equation. This one. Okay, this is the general form of the equation. So we know that what we need center. So we have center already. Okay, and we need a square and b square. Now we are going to calculate a square and b square. Okay, since this is vertical means this one, vertical, this one. Okay, maybe I sketch here. This is horizontal, this is vertical. So vertical one is here. Alright, so okay, vertical one is here. So from here you see vertex, because they give us vertices. So for the vertex is k plus minus b. Okay, so given already, you see, k plus minus b. So from here very clear, b is square root 3. Alright, b is square root 3, so b square is 3. Okay, so after we have this, then because it is given us the foci, so vertical one foci is here. See, k plus minus c. K plus minus c, so h same. Alright, k we know is 3. Okay, 3. So how to get 4? 3 plus 1. And how to get 2? 3 minus 1. So it's very clear that the foci is 3 plus minus 1. So means that c is actually plus minus 1. This is how we get c, because the formula for foci is c. So c square also 1. Then we use the formula c square is b square minus a square. Alright, why b square minus a square? Because it's vertical. Alright, so b square just now we have already 9. So we rearrange first. So a square is b square minus c square. So just now b square is 3. Alright, c square is 1. So a square is 2. Alright, a square is 2. So we already get our center. Alright, we have center. We have b square. We have a square. Okay, then just sub into your equation of standard form of ellipse here. So x minus -1, so plus 1, y minus 3, then a square, b square equals 1. Okay, so when you do other question when you do other part of question 3, yes, you just follow the same step. Okay, just follow the same step. But it might be horizontally or vertically lah. So you follow this table also. Okay. Alright, next will be question 4. Question 4, they give you equation in general form. They ask you to show that it is ellipse. Alright, so I'm going to discuss 4C. So 4C given you this 4x squared plus 9x squared minus 8x minus 36y plus 4 equals 0. So remember just now I said we have to do completing the square. Alright, so you see that x squared and y squared, the coefficient not the same. So we know that this is ellipse. Okay, so we group x and x together, y and y together. So the constant we shift it to the right hand side. Alright, because to do completing the square, I need 1. So I factorize out 4. So become 4, x squared minus 2x. This one factorize out 9. Become y squared minus 4y. Alright, then we do completing the square for this part. So x minus 1 squared. So you see x squared is this one. 2 multiply x multiply negative 1, negative 2x. And negative 1 squared is plus 1. So it's something extra, plus 1. So I have to minus out. Alright, this one also the same. I see minus 4y. So it's y minus 2 squared. So y squared, this one times this one times this one, negative 4y, right? And negative 2 squared is 4. So 4 is something extra. So I have to minus it out. Okay? Now you see. 4 multiply this one, you get this. 9 multiply this one, you get this. This is minus 4. See? Minus 4. This one minus 36. Minus 36. Minus 4, minus 36, minus 40. Okay? Negative 40 shift here, plus 40. So negative 4 plus 40, 36. Alright? So next step, very simple. We know that the right hand side must be 1. The right hand side must be 1. So how to make this one 1? So multiply 1 over 36. Okay? So when this one multiply 1 over 36, 4 and 36 simplify 9. When 9 multiply 36, 9 simplified with 36, 4. This one 1. Alright? So when you're able to express in this form, then you say, oh, this is the standard form of an ellipse. So it already showed that it is ellipse. And because you see, a square is bigger. Alright? A square is bigger. So we know that it's a horizontal one. Alright? When it is horizontal one, so all the y are the same. Because horizontal line, all the y same, right? So the question, because next the question want you to find the center, vertices, and also the foci. Alright? So from here, I get the center, 1 and 2. Correct? So I know that for vertices and foci, all the y are the same. So I write here first. Okay? All the y are the same. Okay? So for vertex, h plus minus a. H is 1. A is 3. A is 3 because this is 3 square. So 1 plus 3, 4. 1 minus 3, negative 2. So this is a vertex. 4, 2 and negative 2, 2. Okay. And for foci, okay, y coordinate same. So h plus minus c. So we need to calculate c lah. I do it here. So 9 minus 4 same lah. Again, consequently, all the c is plus minus square root 5. Okay, so c is plus minus square root 5. Okay, therefore, the foci will be 4 plus square root 5. Another one is 4 minus square root 5. We express everything in exact form. We don't use decimal. Okay, so this is question 4. So I have discussed C. So either you do as homework and also you follow the same step. Then you will get it. Okay, only when come to vertices and foci, please refer to this table. Alright, so these are the question in your textbook. Okay, so now we will see some extra question. Before this, so your homework will be checkpoint 5.2. Question 2, you do A and D. B and C I have discussed. You do A and D. Question 3, you do A and C. Question 4, you do B and D. Alright? As a homework. Alright, so we will go to some other question. Alright, so this question 2 also you do as homework. It's like your question 4 just now. Like your question 4 in your checkpoint just now. You are given it in standard form. In general form. Show that it is ellipse. Show that it is ellipse. So what you need to do is, you have to do completing the square to express it in standard form. Alright? Then of course you can get your center, vertex, foci. Then you can sketch it. So this one you do as your homework. Alright, I will go to question 3. Alright, I will go to question 3. So you see, you are given that focus 1 is 1, 2. Focus 2 is 3, 4. A point P moves in the plane in such a way that at any instant, PF1 and PF2, when I add it, the sum of PF1, PF2 equals to a constant 4. So when you see this definition, you know that it is an ellipse, right? So they want you to find the locus of P. Means they want you to find the equation of the ellipse. Okay, I special find this question is, this is actually an ellipse in this shape. Okay, maybe you will say how I know. Yes, very simple. You see for foci, either if horizontally, the y is always the same. If vertically, the x always the same. But you see these two foci, x and y not the same. So I know that it is in this shape. It's like this. So it's an ellipse. Okay, so let's see how I can get the ellipse equation. Still use the, even though it's in the oblique position, but the definition is still the same. So we still can do. It's just like what we have done the last video, right? How we find the, the last two video, that how we find the equation of the ellipse. Start with the definition like this. Alright, so for the oblique one, also the same. Okay, so let's see how. So everyone can see. Okay. So I push up a bit. Okay. Okay, so you see, you are given the focus F1, 1, 2, F2, 3, 4. P is a moving point, so XY lor. Okay, so the definition for the ellipse is PF1 plus PF2 equals 4. So I rearrange this. I rearrange first. Remember, we shift this one here. So use the formula for distance, PF1. So x minus x, y minus y, square root. Alright, 4 minus PF2. So P and F2. So you get this. Alright, so the next step is squaring both sides. Squaring both sides. So left hand side squaring both sides, no more square root. Right hand side squaring, we have to expand. So first term square, so 16. Second term square, so plus. This one square, no more square root, only the inside. Okay, then 2 multiply 4 multiply this, so negative 8 and the square root of this thing. Okay, I have not enough space, so I write it here. Okay, so this is squaring both sides. Now we expand and simplify them. So expand x minus 1 square is this. Expand y minus 2 square is this one. Alright, so 16 remain the same. Expand x minus 3 square, again, these 3 terms. Expand y minus 4 square, 4 square, these 3 terms. Minus 8. Okay, this one not enough space. I Actually, it's this thing Okay. Okay, next step. So I'm going to simplify. So I move this term, minus 8 square root, this term to this side. Alright, the rest all shift to the right hand side. Okay, the rest all shift to the right hand side. So you see, before shift, x square, no more. Y square, no more. Okay, then minus 2x shift here, plus 2x. So negative 6 plus 2, negative 4x. Alright, then negative 4y shift here. So negative 4y shift here, plus 4y. So negative 8y plus 4y, negative 4y. Okay, then numbers. This is 1, this is 4. So 5 plus 5. Plus 5 shift here. Plus 5 shift here. Correct. 9 minus 5, 4. 4 plus 16, 20. Okay. Then I see 8, 4, 4, 20. I simplified by 4 lah. So 2, 1, 1, 5 lah. Okay. Then squaring both sides again to eliminate this. So 2 square, 4. This one squaring, no more square root. So I write back this thing. Okay. This one is minus x minus y plus 5. Minus x minus y plus 5. Square means multiply them itself lah. Later I expand. Okay. Now expand. So 4. So x minus 3 square is this one. Y minus 4 square is this one. Alright. And this one. Just same as quadratic. I'm going to use the first term. Multiply with this all 3. So negative x, x squared. Negative x, negative y plus xy. So you see, it obtained the terms xy. So negative x, 5, negative 5x. So after first term, second term, I'm going to use negative y, multiply all these 3 terms. So negative y, negative x plus xy. Negative y plus y squared. Negative y, 5, negative 5y. Okay, then the numbers 5 multiply these 3. So minus 5x minus 5y plus 25. See, this is how you expand. Many terms lah, so have to be very careful. Okay, next, I multiplied the 4 in. Multiplied the 4 inside. So 4x squared minus 24x, 4y squared minus 32. So 9 plus 16 is 25. Okay, 9 plus 16, 25. So 25 times 4, 100. Okay, so this one also x squared. I just rearrange only. X squared plus y squared. So xy plus xy to xy. Minus 5x minus 5x minus 10x. Minus 5y minus 5y minus 10y. 25. Okay, so next again, simplify. So x squared move here. So 4x squared minus x squared, 3x squared. Y squared shift here. So 4y squared minus y squared, 3y squared. Okay, so I only have xy here. So my plus 2xy shift here, minus 2xy. Minus 10x shift here, plus 10x. Minus 24 plus 10. Can see Oh, can see So go up a bit. Okay, minus 10 shift here plus 10. So minus 24 plus 10, minus 14. Minus 10y shift here, plus 10y. So negative 32 plus 10, negative 22. Alright, so 25 shift here, minus 25. So 100 minus 25, 75. Okay, so just to show you one example. So this is the equation of the ellipse. Alright, so again you see the coefficient for x squared and y squared same, but it has the terms xy. So we know that this is an ellipse in the oblique position. Alright, so remember just now they give us the focus. So I mark the focus 1, 2, and 3, 4. They never ask us to sketch, but I just show you only. So this one will be the major axis. This is the major axis because major axis passes through all the focus vertexes, right? Then I sketch But from this one, actually we can't find the vertex. We can't find the vertex, but we can find the center. Center is the midpoint, center is the midpoint. We can find center, but we can't find the vertex. And we cannot do the completing the square also because it has xy. Alright, therefore it is not in the syllabus It is not in STPM syllabus